Good morning, everyone. So just like I said in the beginning in this title, today we're going to be working on laser targets. Targets for the ride with the laser gun. So basically the idea is I have these boxes here. These boxes are attached to power supplies, which go throughout the ride space. And then inside the box, there's going to be a Raspberry Pi Pico W, which can talk to the main control system over Wi-Fi. It has a power supply and a special radio module that you're going to have to watch my next video to find out why there's a radio module in here. But what we're talking about today is all these pin headers that are actually to go to laser targets. So then for laser targets, I have a bunch of boards that look a lot like this. So on this board, I have the IR, or I'm going to have an IR receiver module, just like we had in the laser gun video about the ride project. So I've got the IR receiver sits right in the middle, and then on the other three sides, there's going to be LEDs. These LEDs are actually RGB LEDs so that they can change color. And then I have a little bit of transistor driver tree circuit for the three LEDs, since the Pico can't source that much current to drive all three LEDs at once out of its GPIO. So my idea here is each of the three LEDs, or all three of the LEDs, can change between red, blue, and a purpley pink kind of color. So what I'm going to do is, while you're riding the ride, the LEDs can change color, or maybe they'll be able to be programmed in such a way that when you shoot the target, you get a number of points based on what color the target is right when you hit it. And that way it adds a little more fun, and it's not just like sharpshooting, there's a little more strategy to the ride. Especially if it's not going to be as decorated as something like a Disney or a Universal ride, then this can add a lot more interest to the ride, having that little bit of strategy within the game. So what we're going to do in this live stream is we're going to design an enclosure for all the targets. A lot like these enclosures I've designed for the power supplies. For the power supplies and controllers, that just sits in there. And then it has a spot for all the wires to the targets to come out, and a spot for the power jack. Just like I have in this one, I have the power jack there. So I'm going to first design an enclosure like that for these targets. And I actually want to make two different versions of the enclosure. One is just going to be round, and it can basically be pinned up to the wall. And then the other will have a flat bottom so it can sit on the ground or on a table or something, just to give me a little more variety of where I can place the targets to make the ride a little more fun. And then once we have that designed, and both versions designed, we're going to end up doing a little bit of soldering on stream. So I have the three Raspberry Pi Pico Ws, one for each of these boxes. Lost it. One for each of these boxes, so I have to solder the pin header on here so they can connect to these PCBs. And then I have, look at this, a ginormous stack of PCBs for targets. I have 23 here and one more, so 24 in total. I don't have all the components to solder all these up yet, but we can solder quite a bit of them. So with that, let's get into CAD and we can talk about the enclosures I've already designed. Let me do this. So now let's get into CAD and we can talk about the enclosures I've already designed, and then design our new ones. So these are the enclosures for the microcontrollers and power supplies and radio modules, like we've already talked about. So if we look at it, here, let me come to full. So if we look at it, there's three main parts. There's the back plane in here, which holds the 3 different components. And the reason I designed it like this is that I can mount all 3 of them on a little back plane, wire it all up, which I haven't done yet, and then put it into the box. And then it just sits there super nice. And if I ever have to take it out to reprogram, not to reprogram, but to rewire or fix anything, I can just take it out of the box, and it's super easy to work on outside of the box. And then, so there's the back plane, and then there's the bottom of the enclosure. Let's do this one. Bottom of the enclosure, and that's this box that I have here. So just like I said before, it's got the spot for the power jack, the opening for all the target wires, and then a spot to plug in the USB to the Raspberry Pi Pico without taking the whole thing out, so I can actually program them without taking it all apart. And then it's got a lid. I threw my logo on there just for fun, but what's actually most interesting about this lid is that it's a snap-on lid. So the way this system works is there's this little groove here on the lid which connects to this triangle spot right here on the box. And basically when you push the lid down, it spreads these walls out, and then they spring back in place to hold the lid on. And we can actually see that in action here. So if I have one of these boxes, you can see the triangle bit here. It's a little harder to see when it's on black. And then the groove here for it to go into. And if you just put it in and press fit, it snaps really loud, and then the lid's on the box. And it forms this really nice connection. It's a little wiggly, but it forms a really nice connection, and there's nothing to fall apart there. So I actually want to use this same snap-on design for the target enclosure. Is there anything else fun here to see? And because the targets are all on one PCB, because they're all on one PCB like this, I don't actually need that backplane type thing. I can just screw down the PCB directly. And then the last efficiency I want to do is in this other box, I designed this whole back part, so the box actually has a back. I won't need this for the laser target because this can just sit basically and be the back of the target. So I don't need to 3D print out a big sheet of plastic along the back. I basically just need the walls and the top. So with that, let's kind of get into CADing. Now the only thing I've done here is I went into KiCad and exported a 3D model of the target PCB. And that PCB is just going to chill here, and it's going to be a reference for our design of the enclosure. I think I'm going to start with the with just like a base model for the target for the enclosure, and then I'll branch it basically in order to make the one that gets pinned up to a wall, and then the one that sits flat on the ground, a table, anything like that. So to start, I'll work in here. And let's see, how thick did I make the walls here? They are 3mm. So I'll just do a sketch on the top plane. Get some circles going. Bop, bop. And let's measure this circle, it's 80. So we'll do like 82, and then this one needs to be 6mm wider in diameter because it needs 3 extra on each side to make a 3mm thick wall, so that's going to be 88. And then if I just extrude this outer wall by like 25mm, should be fine. Then I'll come into the assembly just for fun, and let's insert these parts so we can kind of, look at them in reference to each other. so we have 2 parts here. And you know what? I'll just do, just for reference, I'll do like a fastened mate between here and here so that they're centered to each other. And we don't need this one. Yeah. So now that they're centered to each other, we kind of get the idea of how they sit with each other. And that 2 millimeter of rate of clearance on the side should be fine. So the last thing I'll do is I can actually come in here and do a, let's see, I just found this feature relatively recently and I really like it. I want to do edit in context. So this took me back to the Part Studio 1 where I made the walls, but it left me basically the PCB. It gives me a little bit of reference so I can kind of look at it and use it in context, so I can design the little struts here that are going to come out and screw down to this point. So what I want is a sketch along the bottom of here, and I will use this screw hole. Yep. Okay, and then I will make a and we'll make that like 8 mil. 8 mil should be good. And then I'll come out like this and like this. Then let's grab a tangent to make sure these are nice. Okay, and then I'll do a like 90-degree here. I guess what I really want to do is a construction line, and then I want a perpendicular from here to another one. Q. Let's get a tangent going from here to here. Oh. Yeah, let's get a tangent from here to here, and then a, let's see, perpendicular from here to here. There we go. And then I can get rid of these, and I'll do like a 45-degree angle here. There we go. And then I'll throw on a, nope, okay. Ah. Then we'll do, yep. We'll close this, and we will then extrude this, add to it, and do other direction, maybe like 5 mil. So what this is this is just gonna be a big, basically a big standoff to screw this target to. So if we look back at the full camera view, you can kind of imagine that this sits here, and then there's 3, that enclosure comes around like this. Then there's 3 of those triangle bits that stick out, 1 for each of these screw holes I've left. So if we come back here, we will do that. And then I want a circular pattern. Ooh, not a mirror. Circular pattern. Add this. It can be its own axis. 3 times. There we go. So now I have 3 of them. Boom. There we go. That looks good to me. So then if I come to the assembly, we can get rid of this fastened. We can kind of move this guy out a little bit. And then we can do a fastened mate from here to here. There we go, and that just kind of sits nicely there. So you can see what I meant by I don't need the back, because the PCB is already kind of acting like the back. So it screws down in these three corners here, but then I don't need to have a big sheet of plastic along the back because I have this PCB right here in the middle. And then next up, what I want to do is design the actual front plate of this. And I actually think we can bring this down by a few millimeters as well. So what I'll do is I'll come here and say 20 millimeters thick. The PCB sits there. That looks good to me. And then what do we need? We need a hole right here for the wire to come through to actually connect to this. And then we also need the lid that has the actual little target graphic, as well as the hole in the center for the IR light to hit the IR sensor for the actual target. So let's start with the hole. I think that sounds easiest to me. If I come in here, I want to do plane on here, and let's do a tangent plane. Flip alignment. Okay, never mind then. Let's do a so we want it to be right here on this face, so I will just do basically an offset plane from the front, and we want it 40 millimeters away because the radius, well, not 40, let's see, let's first go in the other direction. So it's going to be 40 plus the millimeter offset plus the 3 millimeter thick wall, so really 44. And that sits there nicely. Then I will create the new sketch here, and it gets to be a circle. And then for the actual wire, what I'm going to use is, one second, I got a bunch of, here I can show you. I got a bunch of this wire from work. Basically it's a bunch of 5-strand, 5-conductor wire. It came off some faulty sensors from work. But I have a bunch of it, and it's going to be perfect for this because 5 strands is actually how much I need to run this target. And the thickness of this wire, how big I need to make the hole, I believe is about 1/4 inch. So I'll put that in for now, and maybe I'll measure it again before I start 3D printing. But 1/4 inch is plenty fine to start modeling with. So then if we come back here, we will do, I mentioned this to be 1/4 inch. And then as far as height, it needs to be the 5 millimeter from the bottom for these stands off, plus the 1.6 millimeter for the height of the PCB. Plus I'll give it like 2 extra millimeters of clearance just for fun. So let's see, 5 plus 1.6 plus 2 plus 1/8 inch gets to be millimeter, millimeter, millimeter. There. Okay. We'll extrude this sketch, remove, other direction. There we go. So there's our wire hole, and if we look back at this in context, you can see the hole is right here. Just enough space to kind of wrap the wires back around into the PCB and zip tie them really tight. so that the wire doesn't experience strain on the solder joint. So I'll just put like a zip tie right around the wire as it comes in this hole. And that's basically a strain relief. So if the wire gets pulled on, it doesn't break off. Okay, that's looking good. And then the last thing is this snap-on roof lid. If we come here, like to the front, basically what we want is a lid that comes around like this. Gonna be a circle, but then it has all the rings of like your standard Target that you'd see. So if we look up like a Target, even in the Target logo, it has these rings. So I want to replicate that, and half of them will be filled with black plastic, half of them will be open, and those open ones are to let the light from the LED come out. And then of course there'll be an open center for the IR light to come in and hit the IR sensor. So if we come back to Part Studio 1, I think this needs to be a little bit taller. Okay. And then we'll do a... So if we look back at how the lid is designed here, it has this triangle bit coming out. And to do that, basically what I did is I made a rectangle and then chamfered all four sides of it. And that rectangle was 6 millimeters deep and however long, it doesn't really matter. So we can do the same thing here, back in this project. And I'll put it at the top and bottom. So if we do a sketch here along the top, and we will just do basically use this, and then we want to offset this by the other direction 6 millimeters. Okay. And then I will put a, let's come back here. Basically we need some lines. Let's do a construction line down the center here. And then I'll put a line, line, and then I'll do a construction line on each of these. Okay, line, construction, I want to be right angle to that. Line, construction, oh. Line, construction, right angle to that other line, and then line, construction, right angle. And the reason I want it to be a right angle is that so when I make this construction line tangent to this inner circle, it makes the, there we go, it makes this other line, the actual line, perpendicular, such that I can do this and say I want it to be like 30 degrees on all of them so that they're all nice and evenly spaced. It's going to be 150 then if you want to be funky. There we go. 30. And then from here to here can be 30. So then if I extrude each of these, add in the opposite direction 6 millimeters, and then I'll do a chamfer on this face, this face, this face, and this face by 3 millimeters. Okay. And then I'll do another chamfer here and here, here and here by 4 millimeters. Sure, why not? Just to make it all kind of sit a little flatter. I see. This one actually should have been 3 millimeters away and then 6 millimeters tall. And you can see now that it's actually sitting a lot flatter. 3 millimeter. Delete that, come back here, grab that edge and that edge. And then also come back along here, just like this. Boop. There we go. So now we have these nice triangle extrusions. And if we look back at it in context, the PCB is chilling there. And these are sitting nice and flat. That's looking good. And then let's design the lid. This gets to be a new sketch along this face. Let's just clean this up a little bit. Then we'll do a circle. Let's just use this. We'll do a circle out to 88, and then we'll do another circle, but we want it to come in a lot more. Another circle. Did I miss? Yeah, I did. Okay, circle, 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 so full. Okay. Let's do this one to be like 78. That's not wide enough. Let's do 70. $55, $40, $25. What would that be? That would be 10. Let's do 57, 44, 29, 31. Then this one gets 2, 4, 6, 18. There we go. And then we'll do the same idea of having some basically we're going to want these struts to come through and actually hold them. And I'm putting these struts in line with the little standoffs because the LEDs I know are in the middle of the standoff. So these struts that are coming through are going to be not in the way of the LED as long as I make sure they're not they're above the standoffs. So let's do this again. There we go. And then we'll do, let's use this, use this, use this. Then we'll grab some construction lines from here to here. Line, construction, oh. Line, oh. Line, construction, line, construction, and then we'll get parallel to here, to here, to here, to here, to here, to here. And then let's say we want them to be 8 millimeters wide, so 4 on each side. There we go. And I'll just do this on all 4 sides. All 3 of them. Oops. from here to here, 4 millimeter, 4 millimeter, 4 millimeter. Okay. And now if we come and extrude this, we want this face, this face, this face, this face. There we go. And we only want this to be 3 millimeters thick, just like the walls. And then I didn't actually want that to be, I want that to be a new part. So then if we just, well, let's get the little clips on the back side in. So basically what we're going to want to do is we want to make a little ridge around the side here so that it sits nicely and light doesn't leak out the sides. And then the other thing we want to do is to make the little clips for these to clip into. So if we look back here on this lid, what I'm talking about, so let's hide that. I have the lip along here, and then I also have the spots for these to clip into. So how did I make these? Let's see. Let's extrude. Oh, I see. Oh, cool. Okay. So basically the way these work is I'm going to make a full, basically a full lid along the center of here. And then we're going to shell it out, essentially. So if we get rid of this part, what we're going to do is I also don't want this plane kicking around anymore. Come here, do this. Let's see, we want a circle from here and then a circle to here. In this dimension we want to be at basically 81.5 to give it 0.5 millimeter of clearance on both sides. 81. If I extrude this out by 6 mil, there we go, that's not hiding anything. And then if I bring this other part back in context, let's see. I need to, basically what I need to do is right along, see how I have these triangle parts? What I need to do is find a way to make the same indent on this other side. I'm almost wondering if I do like a let's think, how do I do this? I do like a I could almost do like a Boolean subtract from tools, and then target gets to be here, then offset gets to be here. I see. So we'll do boolean subtract. The tool gets to be the main housing. The target gets to be the little one. Then we'll do an offset, and we just want it on these faces, basically, on the faces of the little triangle bit. And we want the offset to be basically like 0.2. Just enough to give it like a little bit of a gap. And you know what, I'll make it 0.5 just because I'm using like a 0.8 millimeter nozzle on my 3D printer right now. Then we'll keep tools. So then if we do that and we come back and look at this part 1, it has the indent, and it also has this whole groove that we wanted. Let's see. And then what we'll do is we will actually just apply a chamfer along this edge and this edge. Not 3 millimeters, but like 1.5 millimeters. Uh, 2 millimeters? Why are you so upset? Let's see. One, 3.4. Let's see, 2. Oops. There we go. So we basically want to just cut a little bit off of here so that, here I can show you. I want to cut just a little bit off of here so that it still grabs, but it doesn't have to deflect so much to go in. You can see I did the same thing here with this chamfer right here. In fact, maybe we can look at here. Yeah, 2 millimeters. So that chamfer worked well on the other one, so let's do the same thing here. 2 millimeter. There we go. And if we look at this back in here, we'll insert the Part Studio 1. I just want the lid though. Do insert Part Studio 1, just the lid. Okay. Then we'll do our fastened mate along this edge to this edge. Let's do actually, just to cheat a little bit and to make sure it's centered, let's do that edge to that edge. So now you can kind of see what I meant. The LEDs here give off light and hopefully illuminate the whole area. And then there's still this hole in the center for the IR sensor to sit on. Still plenty of room for the wire to come in. So that's looking pretty good to me. The only other thing I want to see is if we turn off this, keep the PCB, turn off this base. Just make sure there's no collisions here. It doesn't look like there are, so that's pretty good. So then, like I was saying before, what I really want to do is I want to have I have this base version of the enclosure, and then I want to make 2 versions. I want to make one that can hang on the wall, and then one that can mount or just be set down on a table. So I'm basically just going to duplicate Part Studio 1. There we go. And I'll rename this one to be wall mount. And then I'll rename this one, oops, let's see, this one gets to be floor mount. So wall mount's going to be pretty simple. Basically, all I want to do is I want to have the wire hang out the bottom. Here. I want to have the wire hang out the bottom like this. So it's just coming out straight out the bottom. And I'm just going to put a tab on the exact opposite side that can basically hold a push pin. I'm going to make it really simple with minimal damage to any walls. So I just do a new sketch off the back. Normal. Let's see. Yeah. Come off here, new sketch off the back, and then I'm gonna do bottom. Line through here just for reference, and I want this to here to be like a good 20 millimeters away. I'll give myself a nice circle to work off of, and then a line like that, and a line like that. And I'm basically just making the exact same thing as I had here. So I'll do a tangent, 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 and then I'll do 45, oops, let's do 25 degrees here. And then I'll dimension this to be like a nice 10 millimeter hole. Dimension this to be 25 degrees. I'll figure out the actual size I need for a push pin later, but this should be fine. Just chilling here for a moment. There we go. Then realistically, I think 20 was too much, so I'll just do like a 10 millimeters out here. There we go. So you can kind of see what I meant now. Basically, push pin goes in here, it hangs down, then the wire comes out the bottom, so there's not any weird torques put on by the weight of the wire. So that will be nice, just like that. And then for the floor mount, I want the wire to come out of the side and for there to be a nice flat part down here for it to sit on. So basically what I'm thinking for this one is I come to the normal, wire comes out the side. So I'll just do like this, like a Q, and then I'll do a pop, pop. And then I'll do another line to the other side, make sure it's horizontal. And then I will do like a 30 millimeter, like a 30 millimeter. Honestly, it can just come down like this to match the sides. And then I'll extrude that, both of these, add them in the opposite direction. Not blind, but up to face, and then the face will be this face. So now it has a nice side to sit on here, sit flat with the wire coming out. Yeah. And that still mounts nicely. So I'll just kind of come in and clean up the 3D model a little bit. What I want to do is basically add some fillets around any of these sharp angles, and then I'll add a really small chamfer to basically everything. It makes it 3D print a little bit nicer, as well as just look better in the CAD. So I'll come like this on every side. There we go. And I'll do it on this side too, just for fun. So that will just make it a little bit stronger and maybe look a little bit better. Big as these are. So I noticed on the PCB themselves, they're 3.2 millimeter holes. And that's so the screw goes through nicely without needing to cut threads in the fiberglass. But in the actual plastic, I want it to cut threads. So when I used these holes from the PCB, they were 3.2. But for the actual plastic, I want them to be 3, which is why I just went in and added that hole. Now in this extrude, I want to have the 3 millimeter hole be the one that gets used as the cutout, so that the hole is only 3 millimeters and there's some space for the cut to be made. Space for the threads to be cut as I screw it in. There we go. And then I'm just going to come in with a chamfer on basically every face like this. And just do like a 0.5 millimeter. See. Well, so that's the idea. Before I 3D print this, I will come through, add some chamfers to everything just to make them a little prettier. Then I'll do the same thing on the floor mount. So that's the idea. I have the LEDs, and then I have the enclosure. And now that we have the enclosure set up, I think what we should do is there we go. Okay. Let's see. This needs to come here. That goes there. There we go. Yep. So there's the enclosure. And then the other thing we're going to do now that we have the enclosure is we're going to go back to our actual PCBs here. And then we're going to start soldering some of them. Now, one thing about these PCBs is that as I was designing them, I did make a bit of an error and included some resistors that don't need to be there. So what I'm going to do is right here where I put a resistor, I'm going to put a 0 ohm jumper, just a wire basically. And then in this other one, this was a pull-up resistor for the output of the IR receiver, but I actually don't need that because the Raspberry Pi Pico this is connecting to already has a pull-up resistor built in. So that's not necessary. So what I'm going to do is just leave this one empty and add a 0 ohm resistor to all of these. Not even a resistor, just a jumper wire. So if we come over here to our soldering station, before I actually solder up a bunch of these targets, what I need to do is take my Raspberry Pi Pico W's here and add some pin headers to them. This is actually the first time I've opened up these Raspberry Pi Pico, so I'm pretty excited to get these going. Let me pause this for So these Raspberry Pi Picos, they're the W variety. It's actually the Raspberry Pi Pico 2, which is the first time I've used a Raspberry Pi Pico 2 either. So this will be pretty exciting. Let me open these. The Raspberry Pi Pico 2 came out a few months ago at this point, but it promised higher performance, more capabilities, all while still using the same code, same footprint we're used to from the Raspberry Pi Pico 1. And these Ws, again, come with this Wi-Fi chip on board that'll let me use the Picos to talk to the main control board. And these will just sit here, chilling on the board. So let's get the pin headers soldered on here. When I'm doing this, I actually prefer to basically like put the pin headers into a, get you guys a better view here. Basically, I like to put the pin headers into a breadboard or a PCB meant to mount them, because then it's really simple to whoa. I like doing it this way because it makes it really simple to ensure they're lined up and straight. 1, 2, 3, 4, 10, 11, 12, 13, 14, 15. There we go. Cut that there. 20. So if I just put these male pin headers into the female board, and then the Raspberry Pi Pico on top of that, it's basically guaranteed that the pin header will be straight, and it won't be hard to put into other female pins in the future. So now that that's in, I can basically just run along and solder every single face, which is very easy to do. Once it heats up a little bit. There we go. Tin the tip a little bit. And boom. Here, can you guys see? Not really. Oops. So I'm just soldering pin header on these microcontrollers so that they're easier to work with. A little bit easier to work with. Now, of course, what I could have done is I could have designed the PCBs for the Raspberry Pi Picos to solder onto directly, but I never liked doing that because even though the Picos are really cheap, they're not like free. I don't like using them as disposable because they're so powerful. It just feels wrong to throw them away if something else goes wrong on the board. So I always like to have them be removable by pin header, such that I don't need to waste them if something else goes wrong. Especially with the supply chain regarding anything relating to Raspberry Pis. it just takes longer and longer to get a new board if anything goes wrong. So that's 1/2 of the pin header done on that side. And on this other side, we'll do the same thing. So there we go. One Raspberry Pi soldered up. Pretty. And 2 more to go. Okay. Again, another 1/2 done. See if I can get you guys a view there. another one done. Ooh, those get really hot. Let's and last one. One half done. I'm gonna let this sit for a little bit because it's kind of getting really hot. So while that's sitting, let's take another look at this board, the target board. So like I mentioned, 0 ohm resistor there, basically just a little jumper. Receiver goes here, chills there. LEDs in the 4 corners, transistors, and a bunch of resistors. Might as well get soldering all that. Here we go. So wire soldered on, resistor soldered on. Let's get some of the LEDs out, actually. Let's see, where did I put them? Where did I put them? Not in there. Here. Oh. The hardest part about soldering these boards I found is actually just soldering on the LEDs. Because they have so much smaller contacts, you can actually kind of see those are 4 contacts for the LEDs, whereas something like this jumper here, has a lot more contacts that are harder to work with. Easier to work with because they're so much bigger. But regardless, we can make stuff happen. Let's just put that in, just like that. There we go. And the other nice thing is that they do sit all the way flat to the board. wonder. That'll make it easier. Okay, then we'll just go ahead. I need like the tiniest bit of solder per solder pad. And I used too much. See, right there, I bridged the last two contacts, unfortunately. Fortunately, though, it is a fairly simple fix. I'm going to use one of these solder suckers. This is actually a pretty cool tool. If you've never seen one before, it's just a vacuum. So you press it down with a big spring, and then when you launch it, it creates a vacuum here. You can kind of hear it if I do this. You can hear it bounce off. So what I'll do is I'll just get this solder hot where it's bridging and then suck it up. And then it just sucks up the liquid. Sometimes it'll fall out. But now you can actually see right there each of the joins. See if we can get it to focus. Well, each of those joins, each of those solder points are independent now. They're not overriding each other. So I'll just cut the leads. I'll just bend them out of the way for now. I'll cut them. And then it's the same thing over and over again, basically. And I did the same thing again because these are tiny little joints that are hard to get. And then let's do the final LED down here. Pop. 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 Look at that. First try. Didn't mess up the solder this time. And then we will cut these just like that. There we go. That's the way to do it. That is perfect. Okay. Then there's a bunch of resistors per LED, some transistors. That's about it. So let me do the LED resistors first because there's 6 of them. So I'll grab 2, 3, 4, 5, 6. Next up, I'll do some resistors for the transistors. So these resistors are the ones that drive the current into the base of the transistor, so that the transistor opens up and sends current to the LEDs to turn them on. There we go. And then the last thing to put on here are the actual transistors themselves. So let me just get some of those. And these are a lot like the LEDs, how they have the tiny little contacts that are much harder to solder. But there's only 3 of them instead of 4, so it's a little bit easier in that regard, I suppose. There we go. You just need the tiniest little bit of solder on there to make that work. Oops. And then the last board goes here. This one sits right here. There we go. Both transistors soldered on. So that's basically the process of soldering one of these boards. With that, I think I'm going to end this live stream. Thank you all for joining. Next time when we work on this, thank you all for joining in this project, watching me work on this project. So the main video for this project is going to come out this week. So be sure to tune in for that to see why, first off, why there's a little radio module going in these boxes that control the targets, and then also how I got all these targets working. So thank you again for watching. I'll see you next week at the same time. We'll have another live stream. Thank you.